All right, we're back. We're still on page 125. We are talking about unit vectors and direction angles, and we found that there's this huge connection between unit vectors and the unit circle, which isn't so surprising based on the name. And what we want to do is I'm going to show you how to use your calculator to do a little bit of what we did, actually all of what we did basically. And then we're going to do these problems where maybe the angles aren't as nice. So all of these turned out to be famous, and we were able to do them just by remembering the unit circle. So what I'm going to do is switch over to the calculator. So when I do that, you should also do that. Like you should be taking out your calculator, pressing the buttons. I know from experience that watching someone press the buttons is not really enough. So I'm going to start a new problem that's stock 4.1. And then, all right, so calculator. Should I do that? I'm going to do these in radians. So doc 7.2, and then change to radian, press OK. All right, so we already know, hopefully, that we can press menu 7 and then C, which is 1 up, or literally just press C. And then I can create a unit vector, right? So unit vector, and then I need to do control, open parentheses to get a bracket, and then just do 12 comma 12 square root of 3, and it gives me my unit vector, which is great. That's the unit vector. That answers that part of this problem. It doesn't tell me the angle, though. So at this point, I have a bunch of options, right? I can do the arctan of square root of 3 over 2 over 1/2, and I get pi over 3, which is what we had. There's like a worse way to do this. Well, let's see if I can remember this. Let's do arctan. This is like if you were going to write a program to do this. So like there's no real reason to do this. I think I want answer like row 1, column 2 divided by answer row 1, column 1. I think this is going to like replace, I don't know. Let's find out. Yes. I don't know what it's showing there, but that's basically what we could have done. Also, you didn't need the unit vector to get the angle. We could have done arctan of 12 square root of 3 over 12. And well, there is our exact value. What I want to show you is another way that we can do this. And if you go menu 7C again, menu 7C, and just kind of read through it, right? We got unit vector, we know what that is. Cross product, no idea. Dot product, no idea. We just don't know these things yet. We will eventually. Convert to polar. That's interesting. I want to use that. So we don't really know anything about polar just yet. We'll know a lot more about it soon, and then even more later. But convert to polar. So what I'm going to do, well, I'm going to press enter, and you'll see what happens here. So this is one of those things where first you have to type in the thing and then tell the calculator to convert it to polar. So we don't know what polar is just yet. Let me just press enter on this, and we'll see if we can like figure out from that. So it's giving me a 1 and then an angle of pi over 3. So that's interesting. Pi over 3, I definitely knew was the direction angle. So that might be useful. And 1, this is a unit vector. So 1 might be the magnitude. Let me try it again on this. So first you put in your vector, then you go menu 7C, then you choose convert to polar. So here, I think that the magnitude of this vector is 24. So I think this is going to give me 24 and then pi over 3 again. And it does. This is awesome. So what this is doing is it's telling me the magnitude of the vector and the direction angle. Now the question is, will it get the direction angle right? Will it follow the rules? So if I do, let's see. So it's not, by the way, it's not giving me the unit vector, which is kind of weird, right? Like I can either ask for the unit vector or I can ask for the magnitude and the direction. If I know the magnitude and the direction angle, I basically know the vector, right? I know that this vector is 24 times cosine pi over 3 comma sine of pi over 3. That's all I really need. So let's see what it does with, well, this one fits, this one works, but let's do it anyway, 1/4. So this should give me, I think, 1/2 and then an angle of 5 pi over 6. And it does, awesome. All right, here comes the test. So this one doesn't fit, okay. So this one, if we just do arctan, it will get it wrong. If I do arctan of 1/4 divided by, no, of whatever, of y over x, it would be, oh my God, what is this? All right, hold on. Let me focus for a second. So I want to do 7/2, comma, -21/2 square root of 3. Okay, so if I just did arctan of this, it would give me what would it give me? Oh no, it would give me the right thing. All right, let's not think about that one too much. Oh, because all my okay, well, yeah, that worked. Because it did arctan and it gets it right. So 7, and then our direction angle is right. Let's try it again. So 0 and -19/3. So this is going to give me -pi/2. What's interesting is that arctan doesn't even work on this. Like, it doesn't exist. So what are we going to get? Somehow this knows it. Somehow it knows what to do. How does it know what to do? Debatable. Who knows? But this is kind of really interesting. Because now, if you ever forget like a unit circle point, and you're just like, oh man, what is negative square root of 3/2, comma 1/2? Like, what does that go with, right? So arctan would tell you that's a 4th quadrant angle, because you can do arctan of a negative. You know that it's a 2nd quadrant angle. This tells you that it's 5/6. This is like, it's using a different version of arctan. Sometimes this arctan is defined as like atan 2. I don't think that exists here. Nope. Imagine if it did and I just like had never known. No, it doesn't. So polar is this like other way of thinking about things where you know like a magnitude, and it's very much a vector-y thing, you know, a magnitude and a direction angle. And knowing that basically tells you what you're dealing with. So let's go back to the notes, and we will do the next part and see what we get. So these are going to be ugly angles, and then we'll come back to the calculator and have the calculator tell us the I guess approximate. So find the exact direction and approximate direction angle of each it should just say exact and approximate direction angles of each of the following, but whatever. All right, so 12/5 is quadrant 1. So I'm going to say that the angle is just the inverse tangent of 5/12. And then I would need a calculator for that. So I'll say that's approximately, and then we'll do that. So so it's helpful to like sketch them. You don't really need to sketch them so much as know what quadrant they're in. So this will be pi minus tan inverse of 9/19, approximately something. So now here we run into an issue, kind of. So it's here, right? Maybe I should do a better job. It's here. So like I am inclined to say that this would have been, like, this is what I wanted to do. So I want to do pi plus the reference angle. I can't do that because pi plus something is not between -pi and pi. So instead, I need to come up with something. So let's just write the way we would have done it. So this is, I'll do it in a different color because this is not right. So theta sub question mark is pi plus inverse tangent of 11/18, right? Absolute values, or just negative/negative. Not allowed to do that though, because this is greater than pi. So what I'm going to do is just find the coterminal. I'm just going to subtract 2 pi. So if I subtract 2 pi, I will get the actual thing. So subtract 2 pi. Pi minus 2 pi is -pi, and then plus tan inverse of 11/18. But think about that, like think about physically doing that, right? So what you do is you first go -pi, right? So this would have been -pi, and then you go. Well, I feel like I should use a different color. So you go this way, right? That's your reference angle. So you have -pi, and then you go your reference angle, which is, I guess, this color. So that's another way to think about it. Like, you could just do what you have to decide like what you want to do, right? So I actually prefer to think of this one as first go -pi and then go the reference angle forward. It always reminds me of like opening a combination lock where you have to like spin one way and then spin the other way. So first spin negative pi, then go back the reference angle, and then boom, the lock opens, or whatever, however you want to think about it. And then here, it's going to be like here. So this one's not as bad. Third quadrant, as with all things, the third quadrant is the worst. It's just like why's it got to be like that? All right, so this, we're just going to do the negative of the reference angle. And there's no point in simplifying this because you do not know the arctan of 2/5 any better than you know the arctan of 4/10, and your calculator is just going to do the work. So we're going to do these in radians. So let's go to the calculator, and we'll do it I'll do it 2 ways. I'll do like each of them consecutively 2 different ways. You'll see what I mean by that, I think. So first, I'm just going to do the arctan of 5/12 and get a decimal. So 0.395. So 0.395, just handwriting that in. Now what I'm going to do is I'm going to convert the vector to polar. So remember, another way of getting a vector is the templates. So honestly, if you're just doing a lot of vector stuff, the template always stays on the last template that you used. So like you could just do this and it would be set up for you like pretty quickly. And then we want to convert. So it's menu 7C. And then I'm going to convert to polar, which is going to tell me the magnitude and the direction angle. So if I do this, it gives me the exact. If I do this, it gives me 0.395. So got it right. Let's try the next one. So I'm saying it's pi minus arctan of 9/19, get a decimal, 2.699. 2.699. 3 decimals always. If you haven't figured that out yet, I don't know what you've been doing. I'm gonna do the template thing because now I've decided that's fast. And then menu 7C option 4 is convert to polar. So I'll just do control enter. It gives me, so if I do regular enter, it gives me the exact values, which is really interesting that it's like giving exact values too, right? So that's crazy. But anyway, that's what we got. So here I want to do, so I'm checking the next one, negative pi plus arctan of 11/18. So negative 2.593, negative 2.593. Okay, so let's try the other thing. So I'm just going to copy and paste. And then delete you. And then I've decided this is fast. And go negative 18, negative 11. All right, so this should tell me let's get the exact value. So square root of 445, whatever. We never even needed to figure that out for this problem. And then it's giving me arctan of 11/18 minus pi. I wrote negative pi plus arctan, so it's the same thing. And then the decimal is obviously the same. And then let's just confirm. Well, it won't be confirming it. Oh no, we can get the exact value. Yeah. It's like, let's just confirm this by doing something completely different. So the exact value is negative arctan. It does simplify 4/10, but you know, whatever. So negative 0.381, negative 0.381. Okay, pretty good. So let's go back to the notes so you can see. I handwrote all these in while we were doing it, as hopefully did you. And I think we're good to go. All right, so I'm gonna stop this video here. I'll be back in the next video to do more, and I will see you there.